All right. All right. So, sorry. It appears that my machine ate it partway through. So I see we lost the one person who was watching. Wah wah. So we're back. So we'll be here for another like 10-20 minutes, then I should go make dinner. Then should answer my text messages real quick. Let's see. So we're looking for those asserts. Should know that it's offending. I've written those scripts many times. All right. So this is saying, oh, interesting. So there is disagreement between them about what 0 is. Shice. Okay. So the issue is that the unit thinks it's 0. So obviously that's why it's saying that there's 0 roots. This is saying that it's non-zero. So this diff r. So we know that R1 valid is true. So in order for this statement to be false, this would imply that this is so R1 valid is false. So that implies that this is true. If this is true, that means that this is non-zero. So diff R1 must be something important. I mean, it must be something. So what is it? I have a sneaking suspicion it's something like trailing ones. All right. So we go back in our fancy print. And we want our diff real. And $right. T diff real. And then we want, we'll do like percent 06.6f. This won't line up with anything, so it's going to give me a minor headache. And then I think we did that. Okay, so now we'll be able to see what it was. Alright, so at least we didn't muck up the compiler. It looks like it's printing out. Let's look at the simv.log again. This time we'll look for offending. Boo. So I suspect we need to guard these with something to prevent them from triggering at the beginning of the simulation. Unless it was triggering on the very first one. So this was at 50, which is 50 after 4 cycles later after this. Okay, so it wasn't, they're unrelated. Okay, so we want to look for the next offending. We didn't have to wait too long. the diff real was 1.0625. Whoa, so that's a massive disagreement. Okay. But I mean, like, this is... So... Yeah, but 0.2500. Why is math so hard today? Four times 0.0156. So it's telling me that the difference is 1.0625. Did we forget to divide something important? Like what are we... Oh, yeah. Boo. So copy paste error. This was supposed to be a C, not a B. It makes me more worried about how often we were saying we were okay. Grep offending, start a log. So I believe that's the first. Yep, so those are the first four, so we are happy with the number of roots we have. So that looks like we are functionally correct. From that perspective, we just want to fix these because these are irritating. So I'm cheating here because during reset those are X's, so the if is not going to be true. So what we will do to help ourselves out, so if not, if reset, good. So the reason I'm worrying about these four offendings is that oftentimes I'll jam this into a flow for regression that basically just parses out the number of the raw count of offendings. And we should comment out our super print statement. Boom. Yeah, that'll be funny. We'll do that. There we go. So now it shouldn't yell at us anymore. Or I mean, it won't vomit on the screen. It's still vomiting on the screen because of the compiler and because of some of the statements I have in there helping. So we're starting test good. Okay. And we have this bound variable. So we're doing 8 bits. So that is a lot of tests. 64. Oh, no. So this is like straight across. So these are actually 16-bit numbers. So we should at least do 1024. So we'll do roughly a meg's worth. And then we'll see how we're doing. So this will take a little bit to run, and we'll see how badly we're doing. This isn't a great way to go as far as test running goes. Yeah. So now we're in disagreement on. So we're finding new errors. We're finding lots of new errors. So watching stuff vomit to screen is fun, but maybe what we'll do is that. So I was hoping it would end on its own, so we're going to kill it. The way you kill it is by holding Control-C down a lot, and then be paranoid because it's probably still running. Okay. So good. So this many has errors. So at least we're seeing it. And that was enough that we could probably get a sense of what we're doing wrong here. All right, so let's replace that with that. We're gonna, so not that one. And then all of them were still the R00 error, which is this guy. So we're gonna see what's going on. It could be that when we get bigger, the error is bigger. So we're just gonna try and take a look and see, you know, what do the errors look like, and like how far off are we from being zero. So let's see. So 272 is indeed not 0. 16 is actually much closer to 0. So the problem is that's not that far away from 256. So what was it that pushed us over? So that one's pretty big. 310, 326. Yeah, these get so that one's 450. 0Z. So that should give me that line from simv.log. Yeah, as big as 500. Yeah, so it's like eating up at least 2 bits that I'm not expecting. Yeah, 532 again. Yeah, so we're like a good bit off. Interesting. Interesting. Okay, so I think, so let's go back to our to-do. So we did add a test to see if root counts are wrong, and so far it looks like we're in agreement. We did this with the I2R. We got this guy. We actually ran it, so we're doing good there. So what do we need to do next? So it looks like we have an ongoing error. So instead of calculating error in 0, let's just calculate the error in the root itself. So use I2R again. And then compare real to fixed to determine the absolute error. Absolute error should be LSB of fixed point root. Yeah, I think in my error analysis, I forgot that when you do, because really what we're doing is B. Yeah, we have x squared plus 2b plus bx plus c. So the error here, so if the LSB is off, we're going to be off by 2x plus b. Yeah, that's right. So the error is 2x plus b. And so we didn't notice this before. So the reason we didn't notice this before is because the numbers were so small that making that minor tweak fixed it. And then we may have just gotten lucky in that range that the roots that we were looking at were really tiny. But in this case, as we made the numbers bigger, so this is what was blowing it up, is as the root x is bigger, the error is going to be, so the way to think about it is you add 1, so you're sort of calculating the difference between this expression and the expression with x plus 1 in it. And so that's roughly going to be 2x plus b, right? It's because if you can think of it as being it's actually exactly the derivative. That's exactly what's going on. So when the numbers got big, our error got bigger. When the numbers were small and b was small, our error was small. So this is a problem with our test. So this is one of the challenges with doing numerical methods wrong, is that you certainly won't be wrong. You certainly will spend a lot of time being frustrated why your answer isn't right. So this is certainly think more thoughtfully about your error model. So, we should be able to go through and add this expression. So, step E is actually check numerical methods error, which should be plus or minus 2x plus b. So we'll do that next time too. So hopefully what we find is that the hardware is right and the test is wrong. The ongoing journey of John being bad at writing test benches. So one nice thing is that there should be a super robust test bench when we're done. The other is that this ends up being pretty good at doing because we're using the asserts. It's a little easier to check the formal properties. So if somebody did want to come along later and validate this using more formal methods, they might be able to. I've been doing some reading lately saying that if we one clever thing to do would be to add a coverage statement that we should really coverage, we should have coverage for R0 valid and R1 valid, that we should see a range of these things. We could probably add a coverage statement for each bit too of the input, we should see at least 0 and 1 of each input bit. If not, the test might be a little suspect. But cool. All right, so it's 7. I need to get home to make some dinner for my family. But I think we're leaving it at a good place, and we did the stuff we said we were going to do. It just turned out to not be enough. If I do this in advance, I'll record it. If I don't, I will try and talk to you guys next Wednesday. I'm on the fence about whether or not to do this again next Wednesday, but I will definitely do it the week after if I don't. Have a wonderful week, and I'll see you next time on Hardware Design.